Right now, this summer, the average American household will spend $784 just to cool their home. That number comes from the National Energy Assistance Directors Association, and it is a 12-year record. Electricity rates just went up another 5.4% nationally in 2026, and the companies selling you refrigerant, ductwork, and monthly electric bills are doing extremely well. Here is what nobody is telling you. The windows already in your home, not special windows, not upgraded windows, the ones sitting in your walls right now, were engineered to do what your air conditioner does. Engineered with enough precision that for over a century, Americans lived through brutal summers without a single compressor, without a single utility bill, and without a single contractor. They used a specific window setup, 2 openings, specific heights, specific sides of the house, and when done correctly, it triggers a physical process so effective that engineering journals in 2026 are still publishing peer-reviewed studies confirming it works. That setup was quietly removed from American building education when central air conditioning went mass market in the 1950s. Not banned, not disproven, just erased from the curriculum of every contractor trained after that decade. An entire generation of builders grew up not knowing it existed, and today, 90% of American homeowners are running windows in exactly the wrong configuration, trapping heat inside rooms that could be cooling themselves for free. Before this video ends, I'm going to show you the exact method, the exact positions, the exact logic behind why it works, and why a $130 billion HVAC industry had every financial reason to make sure you never learned it. I will also take you back 3,300 years to the first time a human civilization solved this exact problem, and show you that the physics they used is identical to what your double-hung window was specifically designed to do. Stay with me. Let me start with a number that should make you furious. Air conditioners alone use 6% of all electricity generated in the United States every year. 6% of an entire national grid, costing American consumers over $29 billion annually just for cooling. Not heating, not water, not lights, just cooling. That is the baseline cost of a system that most of us treat as mandatory infrastructure. Something you cannot live without, something you cannot replace. I want to challenge that assumption directly, because the assumption has a financial beneficiary, and it is not you. The first time I understood what I'm about to explain, I was reading an architectural history of a farmhouse built in 1887 in the Ohio River Valley. The author described summer management in obsessive detail, which windows to open, which to close, what time of morning to seal the house shut, what time of evening to open it again. The language was specific and technical. It described the house as breathing, as though the structure itself was designed with a respiratory system. And reading it made me realize something that had been sitting in front of me my entire life. I had double-hung windows in my house, 2 sashes, top and bottom, both capable of opening independently. And in 30 years, I'd only ever opened the bottom sash, exactly like every neighbor on my block, exactly like every tenant in every apartment building I had ever lived in, all of us using half the mechanism, all of us missing the entire point of why that window was designed the way it was. The civilization that solved this 3,300 years ago, to understand what is happening when you set up your windows correctly, you have to go back to 1300 BC. Not for historical romance, for engineering. Archaeologists excavating near Luxor, Egypt discovered paintings on the walls of Pharaoh Nebamun's royal residence dating to the 19th dynasty. In those paintings, rising above the roofline of the house were triangular structures facing directly into the prevailing wind. Egyptologists at first cataloged them as architectural features. It took decades before the full function was understood. Those structures were malkoffs, wind catchers, towers designed to capture moving air at height, where wind speed is greatest, and funnel it down into the building interior. But the malkoff was not simply catching wind. It was creating a pressure differential. Air forced down through the tower at the windward face simultaneously displaced hot, stale air upward and out through separate high openings on the leeward side. The building was not being ventilated, it was being flushed, continuously, without a single moving part, without electricity that did not exist, without a contractor who was not needed. Pharaoh Nebamun slept in a cool room in the Egyptian summer. The year was 1300 BC. The physics has not changed once since then. Persian builders refined this concept into what they called the bad gear, wind catcher. Ruins of Persian fire temples dating to 3000 BC feature chimney-like towers with no trace of ash, leading Iranian architects to conclude they functioned as ventilation structures, not flues. By the medieval period, Iranian cities like Yazd were dense with bad gear towers, each one a carefully oriented shaft that created 6 to 10 degrees Celsius of cooling without mechanical assistance. You can visit those buildings today. Some of them are still working. The temperature difference is measurable with a thermometer when you step from the street into a Badger-cooled room. Napoleon's expedition to Egypt in 1798 sent back detailed illustrated reports of these structures. European architects studied them, and then, a century later, they built the answer into the windows of every Victorian and Edwardian home in America. The window that was designed to do this. Here is what the HVAC industry does not want you to understand about your double-hung window. It was not designed for light. It was not designed for a view. It was designed to function as a malkoff, as a bad gear, as an active atmospheric management system built into the wall of your home. The double-hung sash window, with its 2 independently movable panels, was the direct architectural answer to the wind catcher. Victorian builders understood something that every contractor trained after 1960 was simply never taught. Heat in a room does not distribute evenly. It stratifies. Hot air rises to the ceiling. Cool air settles near the floor. A room with a single bottom opening allows air to enter, but traps the hottest layer directly overhead with no exit. The heat accumulates. The room gets worse, not better. Open the top sash, and something different happens entirely. The hot air stratified against the ceiling now has an escape route. It exhausts upward and out through the top opening, while atmospheric pressure simultaneously draws cooler, denser air in through the bottom sash. You have built a chimney. The window is now functioning as a bad gear. Warm air rises and exits. Cool air replaces it from below. Continuously, the room flushes itself. Century houses, Victorian and pre-war American homes, were managed this way by people who understood exactly what they were doing. Accounts from the era describe closing windows on the sun side of the house during peak afternoon heat, while opening north-facing windows at the bottom. Warm air exits east. Cool north air enters low. The house breathes on a schedule their owners set by reading the light and feeling the breeze. They were managing airflow the same way an Egyptian stonemason managing a malkoff managed it 3,300 years before. When central air conditioning went mass market after 1955, those techniques were simply abandoned. There was no financial incentive to teach them. A family that opens their windows correctly is a family running the AC less. A family running the AC less is a family buying fewer kilowatt hours. By the 1970s, the double-hung window was being manufactured and installed by contractors who had never been taught what the 2-sash design was actually for. The top sash in most American homes is painted shut, locked into the frame by decades of paint and neglect. A mechanism specifically engineered for active cooling, permanently disabled, in a country spending $29 billion a year on electricity to compensate. That is not an accident. That is a revenue stream. The physics, in plain language. Let me explain exactly what happens inside a room when you set this up correctly, because the science makes the result feel almost unfair. Hot air is less dense than cool air. This is not a theory. This is a measurable, consistent physical property. A room sealed at the top traps hot air against the ceiling, because that air has nowhere to go. It presses down. Your air conditioner fights it for hours. Your electric meter spins. Open the top sash of a double-hung window, even just 4 inches, and you create a pressure differential. The trapped hot air has a path. It exits through the top opening. The room pressure drops slightly at that upper level. Atmospheric pressure outside immediately responds by pushing denser, cooler air in through whatever lower opening you provide. Open the bottom sash of a window on the opposite or perpendicular wall, and you have completed the circuit. Engineering research published in January 2026 from the Energy House. 2.0 laboratory in the United Kingdom tested this stack-driven ventilation at full scale in a controlled chamber with a 20 degrees Celsius temperature difference between inside and outside. The ventilation rates confirmed what Victorian builders already knew from observation. The vertical separation between openings is the critical variable. The greater the height difference between where cool air enters and where hot air exits, the stronger the stack effect becomes. A 2-story home with ground floor bottom sashes open and second floor top sashes open creates the most powerful version of this effect without a single fan running. Separate research from the Architecture Helper Institute found that buildings designed to use cross-ventilation in combination with the stack effect achieve air exchange rates up to 14 times higher than rooms with only 1 opening. And a modest airflow of 160 feet per minute, slow, barely perceptible as a breeze, makes a room feel up to 5 degrees Fahrenheit cooler without altering the actual temperature. The air does not have to be cold, it just has to move. Moving air carries heat away from your skin through convection. Your body reads that as cool. That is why 85 degrees in a breeze feels nothing like 85 degrees in a sealed room. The same physical principle the Egyptian malkoff exploited 3,300 years ago. The exact setup. Here is the complete method. No tools required, no contractor required, nothing to buy. Step 1. Identify which side of your home the prevailing wind comes from. In most of the continental United States, prevailing summer winds come from the southwest. If you are unsure, step outside at mid-morning and wet your finger. You will feel the windward side of your face cooling first. That is your wind direction. Step 2. On the windward side of your home, the side the wind is coming from, open the bottom sash of your double-hung windows. If your top sash is painted or sealed, focus this side on the bottom opening. You want cool, moving air to enter low. Step 3. On the opposite side of your home, the leeward side, open the top sash. This is the critical step most people never take. Open it at least 4 inches. 6 is better. The hot air stratified against your ceiling is looking for this opening. Give it 1. Step 4. On upper floors, reverse the priority. Ground floor bottom, sash open for inlet. Upper floor top, sash open for exhaust. If you have a 2-story home and you set both floors correctly, you have built a whole house ventilation stack. Cool air flows in at grade level, moves through the ground floor, warms slightly, rises naturally through stairwells, and exits through the upper floor top sashes. The house is ventilating itself floor by floor. Step 5. Timing matters more than most people expect. Close everything by 9 or 10 in the morning before the outdoor air heats past indoor temperature. The goal is to trap the cool night air inside the thermal mass of your home's walls and floors, then open the system again after sunset, typically 8 or 9 p.m., when outdoor air drops below indoor temperature again. Victorian households ran this on a strict schedule. Their houses stayed 10 to 15 degrees cooler than the outdoor peak temperature, not because of the windows alone, but because they sealed in the cool and flushed out the heat at the right times. Step 6. If your top sashes are painted shut, and in most American homes they are, run a utility knife carefully along the painted seam between the sash and the frame. Work slowly along all 4 edges. You are not cutting wood, you are separating a paint film. In most cases, the sash will slide freely once the paint bond is broken. This single action, which takes less than 20 minutes, restores the full function of a ventilation mechanism that cost someone money and craftsmanship to build into your home, and that was disabled by nothing more than carelessness. What was removed and why a building industry analyst, reviewing residential construction manuals from 1945 to 1975, would notice something striking. The 1945 editions contained detailed guidance on natural ventilation, cross-ventilation diagrams, stack effect calculations, window placement relative to prevailing winds. This knowledge was considered essential residential construction literacy. By 1975, those sections had been reduced to footnotes. By 1990, they were largely absent. The contractors trained on those updated manuals learned to specify HVAC systems the way a previous generation had learned to specify window placement. The knowledge did not disappear from physics. It disappeared from the curriculum. And the industry that benefited from that disappearance was generating $130 billion annually by the time the removal was complete. You cannot patent the stack effect. You cannot trademark the temperature differential between your ceiling and your floor. You cannot send a monthly bill for air moving through a window opening that has existed since 1300 BC. A 2026 analysis from Electric Choice calculated the current national average electric bill at $163 per month, a 5.4% increase over 2025 alone. The Department of Energy has confirmed that HVAC accounts for 31% of total household electricity consumption. A homeowner in the Pacific Northwest documented her window ventilation experiment in a home improvement forum last summer. Before using the 2-sash setup, her bedroom reached 84 degrees by 3 p.m. despite running a window fan. After implementing the exact method described here, bottom sash open on the north-facing windward window, top sash open on the south-facing leeward window, timing adjusted to match outdoor temperature, her afternoon bedroom peak dropped to 76 degrees. No fan running, no electricity consumed, an 8-degree drop from a window position change. A man in Arizona with a 2-story home ran the same experiment across an entire cooling season and tracked his electricity consumption. He reported a 22% reduction in AC runtime compared to the previous summer. His total investment was the 20 minutes it took to free his painted top sashes with a utility knife. Compare that to a new central air conditioning system. Installation costs between $5,000 and $15,000. Monthly operating costs average $150 to $200 through peak summer months. Over 10 years, you could be looking at $25,000 or more just to push heat out of rooms that should never have been trapping it in the first place. The Egyptians managing the royal residence of Pharaoh Nebamun understood this. Persian city builders managing entire neighborhoods of bad gears understood this. The Victorian carpenter who installed the double-hung sashes in your home understood this. The knowledge was never lost. It was set aside, written out of the training manual, and covered up by an industry that earns $130 billion every year precisely because you believe cooling a home requires equipment, electricity, and a monthly bill. It does not require any of those things. It requires the right 2 openings at the right 2 heights on the right 2 sides of your house. Reclaim the knowledge. Tonight, before you go to bed, do one thing. Find a double-hung window on the leeward side of your home, the side away from the wind. Try the top sash. If it opens freely, open it 4 to 6 inches. On the opposite wall, open the bottom sash of another window. Then stand in the room and give it 15 minutes. You will feel the air move, not the artificial blast of a compressor, the steady, even movement of a room flushing itself. The same movement Nebamun's household felt in 1300 BC. The same movement that cooled Yazdad's streets before electricity existed. The same movement that your window was specifically, deliberately, precisely engineered to create. And when your neighbor asks why your house is cooler than theirs, you can tell them you found the setup. And you can point them here if you have tried the 2-sash method, or if you have an old house whose top sashes are still operational, drop the result in the comments. Before and after temperatures. Location. House age. I want to build a picture of where this works best across the country and how many degrees it is actually moving, because the data that no HVAC company will ever fund, we can build ourselves. Subscribe if you want to keep pulling these threads. The next vault opens soon, and what is waiting inside is the thing underneath your house that has been passively conditioning your basement to 55 degrees year-round since the day the foundation was poured, and how one family in Kentucky connected it to every room in their home without spending $1 on equipment. Stay curious. Stay self-reliant. I will see you next time.